Okay, welcome. So now what we're going to do is we're going to demonstrate using this example how integration by parts works. Okay, so what I want to do is I want to pick a function. So in this case we have a product of functions. Okay, so notice how I can't do a u substitution. This is the one that we started with a couple of videos ago. So at the beginning of the topic. So we can't do u substitution in this case. So, but we can do integration by parts. And so in this case, we've got a product of two functions, and we can't do a u substitution. So let's see if we can do integration by parts by picking v and u such that we get something simpler when we integrate. Okay? Because what we're going to do is we want something that when we take the derivative of this thing, that we're going to get something that's easily integrable, right? So say this is the integral of this function, right? And again, we're looking for u and v because, again, just like with the derivation of the integration by parts, we want to get a u and a v where one of these functions is easy to differentiate, okay? And the other function is easy to integrate, but we want to end up with something simpler than what we started. We don't want something more complicated. Let's just say that. We don't want something more complicated, but we don't want something, we want something easy or at least as complicated, but something that we can then use something else to integrate. So let's use this as an example. Now, here I've got a sine function, which is cyclical, right? So this, I know, is going to continue going to a cyclic pattern. If I take the derivative of this, it's going to give me cosine x. If I take the derivative again, it's going to give me negative sine x, and so on and so forth. Okay, so this at least doesn't get more complicated. And if I integrate it, it's going to go back the same way. But this one, if I integrate this one, it's going to get more and more complicated. It's going to become x squared, and then it's going to become x third, and so on. But if I differentiate this, it's going to get simpler. So I want to make this my u, and I want to make this my dv, because that's what I have to do. I have to pick what my u and my dv is going to be. Because remember, I need the form of u dv, okay? Where if I differentiate this, I'm going to get something simpler, and when I integrate this, I'm not going to get something that's, I'm still going to get something I can use. So now, so in this case, I'm going to let u equal x, and v is going to equal what? Well, if I let dv, let's do this, dv equals sine x dx. Okay, so now let's differentiate this. So if I take the derivative of this, I get du equals dx. And if I integrate this, I get v equals what? What is the integral or the antiderivative of sine x? What is it? So the derivative of what equals sine x? So in this case here, it's going to be what? Sorry about that. So again, all you have to do is just ask yourself what the derivative of what equals sine x. Well, the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of negative sine x is negative cosine x. And the derivative of negative cosine x is sine x. So this is going to be negative cosine x. Okay, so now we've got our pieces, so let's plug it in. So now we just have to plug it into the formula. Remember, the formula is uv minus the integral of v du. And now we just plug it in. So what I'm doing is I'm exchanging this for this. And this integral is the one I want to be able to do something with, right? So if I get something that's complicated, or more complicated here, then that's not going to be good. So let's see what happens. So uv, so this is going to be what? It's going to be x, so negative x cosine x, minus the integral of v, which is what? Negative cosine x, and du, which is dx. Now look at that. Definitely something I can do now. Something I can easily integrate. So now it's going to become what? It's a negative x cosine x. The negatives come out, so that's going to be plus. And the integral of cosine, well, what's the integral of cosine? Sine, right? So this is going to be sine x plus c. And that's it. Have a great day.